Hi everyone. So let's say we have a molecule that looks like this, a 5-carbon ring with a methyl group, two pi bonds, or two double bonds, if you want to say, and a radical over here, so a free electron on this carbon. How many possible resonance structures can be formed here? How many possible resonance structures? So before we begin drawing out the resonance structures, I mean, if you want to eyeball it, if you want to guess, you can try. But the best way to do this is to draw them all out. So before we do that, some key concepts to remember. The first is that because we have a radical here, we are going to be using fishhook arrows. So arrows with only one of these barbs coming out of the end, kind of looking like a fishhook. So fishhook arrows. And these denote the movement of one electron. This is as opposed to the other kind of electron pushing arrow we normally see, this double-headed arrow, which you're probably more familiar with, which is used to show pairs of electrons. And this double-headed arrow is very useful, but because we have a radical here, we want to show the movement of one electron at a time, so we'll be using fishhook arrows. Okay, so also I will be showing the electron pushing arrows in red just to make it easier to visualize, and the structures will be drawn in black. The final concept I want you to know is that remember that this double bond is just a pair of electrons. So remember that covalent bonds are pairs of electrons shared between two atoms. So this would be a single bond. This is a single bond. And if we have a double bond, that's actually two pairs of electrons. This is a double bond. And so these electrons can still move. And we'll be taking advantage of that when we draw our resonance structures. We're going to be moving the electron pairs, or rather the electrons in these double bonds. So let's get to work. So we can begin by moving this radical either clockwise or counterclockwise. It does not matter. I will just go in the clockwise direction. We should get the same result in the end. By the way, whenever you draw resonance structures, you should be able to cycle around electrons or electron pairs until you get the original structure. You have to be able to recover the original structure. If you can't recover it, you either drew a structure wrong or you moved an electron in the wrong position. So remember that resonance is delocalizing electrons. We're going to try to spread out this charge as much as possible. So let's begin by moving this electron in the clockwise position. So remember, fishhook arrows? We're actually going to be moving it onto this carbon-carbon bond. And the reason for that is we can actually form a double bond. How? Well, remember, a double bond is two pairs of electrons. So we need another electron in addition to this radical in order to form a pi bond. And we can get that from this, oh, that's a little thick, this pair of electrons over here, this pi bond. And we can split it up. So we can draw two fishhook arrows coming out of it. So we're going to bring one here. That's going to make a double bond. And then the other electron, we can actually move it up to this carbon to give it another radical. And so you might be starting to get a feeling for a pattern that will form here, because we're going to have a double bond here, a newly formed pi bond. We're going to bring up a radical here, and then this pi bond is going to remain in place. This is not going to move. Well, now we're just going to be cycling a radical in the clockwise direction. We're just going to keep moving it around this ring. And so just as we did in the first one, we're going to bring this electron onto this carbon-carbon bond. And notice how it's adjacent to another pi bond. And we can split this up, actually, just as we did here. And you might be starting to sense a pattern. There's a real pattern going on here. Because now we're going to have a pi bond here. We're going to move the radical into this tertiary position up here, and then this pi bond is going to remain in place. Okay, now, again, we're just going to keep following this pattern of moving this radical in the clockwise direction. We're going to bring this radical onto this carbon-carbon bond. Okay, notice how it's adjacent to a double bond. So we can split this electron pair apart so that we can form one new electron pair here, or rather double bond here, and we can move the other electron into this position and onto this carbon to form another radical. And so we have a double bond over here, double bond up here. This double bond did not move, and we have a radical in this position. Okay? And so finally, well, we have to be able to get back the original structure. So again, we're going to follow this pattern. I'm going to move this electron up here. And notice again, pattern, there's an adjacent double bond here. So we're going to bring one electron here and one electron up here. Again, it's just following the same pattern going around and around. And we should be able to get newly formed pi bond here, radical up here, and this pi bond remains in place. Cycle back this radical down here. Again, we're just going to do this pattern over again. We're going to move this radical again in the clockwise direction. Notice how it's adjacent to this pi bond, and we're going to split it up. Just to make it more clear, actually, this is actually not correct what I drew technically. We want to draw the fishhook arrow coming from the electron we're looking at. So I drew it coming from here. This is wrong. I want to draw it coming from this pi bond into this position. And you're going to end up with double bond, newly formed double bond, radical over here, and this pi bond remains in place. And what do you know? This original structure is the same as the structure we ended up with. And so because we were able to cycle this radical around accurately, and we can recover the original structure, we know for sure that these are the possible resonance structures. So how many possible resonance structures are there for this molecule? Well, let's count them. We have the original structure, 1. We have this resonance structure, again moving this electron around, 2, 3, 4, and 5. This 6th one is not a new structure. This is the same as the original structure. So actually, we can draw our double-headed arrow going this way. So 1, 2, 3, 4, 5 possible resonance structures. And we know it's correct because we can recover the original structure. So key takeaway here, remember to cycle around your electrons. Remember that in order to check your work, you need to be able to recover the original structure. Remember to use fishhook arrows if you have a lone electron. And remember that you can always split these double bonds using 2 fishhook arrows, because double bonds are simply 2 electron pairs. And we can form new double bonds by joining 2 electrons together on a carbon-carbon bond.